So in 7.3, we're going to focus our attention purely on similar triangles, and we're going to start doing proofs again pretty soon. And it's going to just look at different ways that we can assume triangles are similar instead of having to show every step. So let's just start with this. In the two triangles below, if they're similar, find x and then find the perimeter. So based on the markings, I know that 3 corresponds with 9. And I know that 4, either one of them, corresponds with the x plus 5. So cross multiply 9 times 4, that's 36. And then I'm going to distribute that 3. Alright, so when I start solving and subtract 15, 3x equals 21. So x is 7, which means that these are each 12. Well, when I need to find the perimeter, I need to add up all of these sides, 12 plus 12 plus 9. So I get that the perimeter is 33. So take a look at these. What must be true in order for these two triangles to be similar? Well, there were two things that we talked about in 7.2. The angles had to be congruent, 59, 59, 35, 35, 180 minus those, both here and here. So 180 minus 59 minus 35, we get 86 for both here and here. I don't know why I wrote the 86 down there. I meant to write it up here. So both of them are 86, so all three angles are congruent, and the sides have to be proportional. So 6 over 4 has to be the same as 9 over 6, which has to be the same as 10.5 over 7. In fact, they are all 3 over 2. And so they are all proportional, which means those triangles are similar. So we need all the sides to be proportional and all the angles to be congruent. There's 3 ways to prove triangles are similar. Just like when we did triangles congruent, we didn't have to show all 6 pieces, we could only use some of them. So there's 3 that we're going to use. Angle similarity. You only need 2 angles because if you know the 2 angles are congruent, you automatically know the third. So this really is angle, and then in parentheses, angle. Side similarity. So if this was 3, 4, and 5, this would be, let's double it, 6, 8, and 10, because this is twice as big here in all 3 sides. And if all 3 sides are proportional, then all 3 angles are congruent as well. And then the last one is side angle side similarity. So let's call this 3, and let's double it in 6. Let's call this 4, double it and say 8. Now if we know the angle in between is congruent, because the A is in the middle, we know those are congruent, we know that that third side is proportional as well. So determine if these triangles are similar and justify using a postulate. Well, on the first one, I know angles are congruent. I'm going to check proportions. So I'm going to do 36 over 24, and I'm picking 36 and 24 because they're the biggest of the two. You always match smallest side with smallest side and biggest side with biggest side. When you simplify, 20 over 18 becomes 10 over 9, and 36 over 24, both divisible by 10, becomes 3 over 2. So these are no, they're not proportional. When we look at this one over here, I'm going to set up smallest side over smallest side, next smallest side over next smallest side, and biggest side over biggest side. And when I do that, I get 5 over 8 divided by 4, 5 over 8 divided by 3, 5 over 8. So this one is, yes, by side similarity. And when we look at this third one, because they're parallel lines, I know that I have corresponding angles that are congruent, as well as this angle being congruent to itself. And if we remember that property, it's called reflexive property. And this is by angle similarity. So let's go ahead and begin proofs. We know WZ is parallel to XY. So let's get this on here. And that's given to us. And before I do any of this proof, I'm going to start numbering all the angles. And the reason I'm going to number them is it's just going to make it a little bit easier for me to write out a proof. And I know that angle 1 is congruent to angle 2. And the reason is if the lines are parallel, then corresponding angles are congruent. So let's mark those. Let's switch color. You know those are congruent. Step 3, I'm going to say angles 4 and 5 are congruent. And that's by the same reason. If parallel, corresponding angles are congruent. And let's mark those. Now I don't need it, but I'm going to say that angle 3 is congruent to angle 3. And that step is reflexive. And really these 3, you only need 2. I'm running out of room. Only 2. And then because I have 2 angles congruent, this is angle-angle similarity. And the 2 triangles are given to us in that conclusion, WZS, similar to triangle XYS. So let's take a minute, try this one out first on your own, and then let's check. Before you try it, number the angles the same way so that way we can check as we go. Alright, so let's find 2 pairs of angles. I know 3 and 4 are vertical angles. And all vertical angles are congruent. And let's, don't forget to mark those. Because these sides are parallel, I know that I have alternate interior angles. I can use either 1 and 5 or 2 and 6. I'm going to use 1 and 5 as my pair of congruent angles. Angle 1 is congruent to angle 5, and that's because if parallel, then alternate interior angles are congruent. And now remember, I only need 2 pairs of angles, so since I have 2 pairs of angles, triangle EFG, not equal. Let's try that again. Triangle EFG is similar to triangle HIG, and that is by angle-angle similarity. Now you notice we only did 2 examples of proofs, and they were both angle-angle similarity. They're always going to be angle-angle similarity. We're never going to set up a proof where I'm giving you side lengths and you set a proportion in a proof. It's not going to happen. It's always going to be angle-angle similarity. 100% of our proofs in this chapter will be angle-angle similarity.